Aloha class. Today we're continuing chapter 5, polynomials and polynomial functions. And we're getting into section 5.2. And with section 5.2, we deal with what we call polynomials. They're linear factors and they're zeros, okay? And our objective is going to be to analyze factored form of a polynomial and to write polynomial functions from its zeros. So if you remember, when we were solving polynomial functions, that's all we're really doing it now is we're taking it a step further. We're going to use end behaviors and turning points all to hopefully connect all this stuff together, right? That's the beauty of math. One thing links with the other. Now, in order for us to find the zeros and to get started, for first and foremost, we are going to have to write polynomials in factored form. Well, what the heck does that mean? That just means we're going to go back to chapter 4. Okay, that's all it means. And if I have three things right here, remember the first thing we're going to do is we're going to see if there's a great and common factor. So we're going to start with our x cubed, minus 2x squared minus 15x. And if you notice from those three, they all have an x in it. So what I am going to be able to do is take out an x, factor out an x. Remember, factoring is like division. And then remember, whenever we factor something out, we just say, hey, could I maybe keep on going? And in this situation, we could, because that's a trinomial with an ichi out in front, which is sweetie sweets, which means we can do it the super duper fast way. Now, how do we do it the super duper fast way? We do a little side work. This is our x, right? We do 1 times negative 15, which is negative 15. We got a negative 2 right there. What works at home? Well, it's a 5 and a negative 3, Mr. T. No, it's not. That does equal negative 15 when we multiply, but when I combine them, it gives me a positive 2, but we really want a negative 2, so I just got to flip-flop, right? And then it works out beautifully. And then totally in factored form means this right here turns to that, dude. Super duper fast means an x and an x, and that's a minus 5 and a plus 3, and that is what we call a polynomial written in factored form. And if I'm able to do that, we're able to take it to the next step and find the zeros. Okay. All right, let's keep rolling here. We're doing awesome. Let's see, maybe another practice, and for sure there is. Oh my gosh, those guys all have an x in it. Okay, so I'm just going to rewrite my problem. I've got 3 terms. They all have an x in it, so I'm going to factor out the greatest common factor. Remember, factoring is like division, so it's going to take 1 away from all these guys. That definitely looks factorable. I can do it the super duper fast way because that's an ichi right there. So I come over here, a little side work, spling, spling. Multiply the first guy times the last guy. That's a negative 12, a negative 1 in the middle. What works? A 4 and a 3, a 6, a 2, a 12. 4 and 3, the difference is 1, and one's got to be negative, one's got to be positive. Sweet, first try. So now super duper fast is awesome because I just go like that. Spling, spling, and then a negative 4 and a positive 3, and that is what we call in factored form. Not too bad, right? Hopefully you guys are rolling. If we get another one, all right, I'm going to give you guys one more, one of the tougher ones here. Ooh, okay, we've got to do 10, and we have to do 12. We'll do 10 together, and then you guys have to do 12 on your own, all right? Here we go, because this guy might be a little bit different, number 10 here, a little bit more difficult because it has just 2 guys, but I still do the same practice, right? I go ahead and I look, is there anything common with both of those first? And there for sure is. There's both an x. So remember, factoring is like division. Oh, snap. Isn't that difference of squares things Mr. T was talking about? For sure it is, right? That x squared minus 36. Remember, that's x squared minus 6 squared. Ooh, that's the difference of squares. So it's just x minus 6, x plus 6. Remember that? So that guy's factored. Remember, that's whenever we have a difference of 2 squares, we can go ahead and do it that quickly. Boom! Factored form. Woo-hoo! Isn't it fun when we tie it all together in Alg 2? All right, now come on, challenge yourself. You guys have 12. Okay, challenge yourself. Now, it's the hardest one we're doing so far, but I think you guys are so smart, you guys can handle it. So make sure you hit pause and then unpause it, and then we'll do it together. 9x cubed plus 6x squared minus 3x. That's number 12. Boom, boom. They all have an x, but guess what? Hopefully you remembered when you were doing this on your own that they also all have a 3. So I'm going to take out a 3 and an x. Remember, it's division is factoring. So 9 divided by 3, that's 3, and you take away one of the x's and you get that. 6 divided by 3, well, that's 2, and we take out one of the x's, so there we go. Oh my gosh, and a lot of students are going to make this mistake. It's a negative 3x divided by, everything goes away, and people think they just go away. It just doesn't go away. Remember, it's division. So a negative 3x divided by a positive 3x is a negative ichiban. Okay, now, oh snap, that guy has a 3 out in front. Shoot, cannot do it the super duper fast way. So if I can't do it the super duper fast way, I got to do some serious side work and see if I can keep on going. Now, how do I check this? I check my x right here, right? And then I have to multiply the first times the last. That's a negative 3. The middle guy is a 2. All right, what works there? What works there would be a 3 times a 1, right? But one of those guys has to be negative. Let's try that. Oh, sweet, it works out. But I have to be very careful right now. Cannot do it the super duper fast way. So that 3 is going to hang on right there. Okay, and then remember, I write down the first dude. I write down the last dude. Remember that? Instead of writing 2x, I'm going to put those two guys I got. I got a 3x and a negative 1x. All right, then remember, we group those two separated by a minus sign, those two guys. Now, what's common between those first two guys? Well, a 3 and an x, right, class? And then remember, we're factoring that out. Factoring is like division. So 3x squared divided by 3x is an x, and 3x divided by 3x, they all go away. But remember, it's division. So 3x divided by 3x is ichi, so it's going to be a plus 1. Remember, that negative sign carries down. Oh, snap. It looks like there's nothing in common with the second one. Actually, it looks like they both have a negative 1. And remember, when there's nothing in common, there's always a 1 in common. Now, be careful here. If you do negative 1 divided by a negative 1, you're left with a positive x. And a negative 1 divided by a negative 1, once again, it all goes away. But remember, factoring is division. Negative 1 divided by negative 1 is a positive 1. Oh, sweetie sweets. I've got 2 terms left, and they got the same exact thing. So I write my final answer as what is in parentheses there, which is 3x plus, which is x plus 1, right? That goes in the first parentheses, spling, spling. And what's left? 3x minus 1, right? That guy and that guy. And then boom, that is what we call in factored form. If you possibly got that on your own, you are probably going to be money on the next quiz and test. Okay, and if you weren't able to get that on your own, no big deal. We're going to practice these guys in class. And if you continue to struggle, just come in the mornings and we will set you straight. All right, let's go ahead and take it to next level. What are the zeros of this? And it says to graph the function. So believe that's already factored. Well, if it's already factored, we just do this little thing here that we did before, if you remember. Okay, we just go, that's y equals x plus 2, x minus 1, x minus 3. And then we do this little spling, spling. And to find the zeros, you just set each one of your factors equal to 0. Okay, there we go. And if I solve that, that means there is a 0 at negative 2, comma 0. To be a 0 means the y would be 0. Okay, and then we go x minus 1 equals 0. That'd be x equals 1 when I added 1. That means there's a 0 at 1, comma 0. And then my last one would be x minus 3 equals 0, which would be x equals 3, which means it would be 3, comma 0. So ask me to graph this, guys. So let's just do a little sketch over here. And I have zeros at there. There's a 0. Okay, we're going to call that A. Should always label. Okay, we have 1, comma 0. Let's call that B. And let's call that C. Now the question is I've got to graph it. Whew, how am I supposed to graph this? Well, one way is you could multiply all that out. Or you could take my little cheat. How many x's do I have there? I've got x to the, that's to the first, that's to the first, that's to the first. So it's really x to the third. Okay, and if you there's nothing in front there, that's just in ichi, so it's like a 1x to the third. That would be the leading term. Now, if you guys remember, if it's a leading term with 3 as the exponent, which is odd, one goes up, one goes down, right? And then it's a positive one out front, so that means it ends by going up, and it starts down. And it's got to have 3 minus 1 is 2 terms. It's got a term, got a term. Sweet! I was able to graph that just by finding the zeros and using the end behaviors and making sure the turning points worked out. I don't know about you, but that was kind of fun. All right, guess what? That's right, we practice, because practice makes perfect. Now, this one's a little bit different, so let's go ahead and take a look at it. We've got y equals x times the quantity x minus 3, x plus 5. You know what's awesome? This is already factored for us. So if it's already factored for us, now remember, that x right there is really like it is in parentheses. So you go spling, spling. That means I really have 1, 2, 3 different zeros. So the first one is just x equals 0. Oh, nice and easy, Japonesey, right? We're going to call that our A point. And then the next one would be x minus 3 equals 0. Add a 3 on both sides, you get x equals 3. I got 3 comma 0. We'll call that guy B. And then my last one would be x plus 5 equals 0. Subtract 5, I get a negative 5, and I get negative 5. It's a 0 comma 0, and that's C. So now let's just graph that bad boy. That's all it is. All right, there's A. Okay, where's B? 1, 2, 3. There's B, and then 1, 2, 3, 4, 5, and there is C. All right, now let's go ahead and look at this. We need to know the leading term. So one, you can multiply all this out or take my shortcut. How many x's do we have? X to the first, x to the first, x to the first. So there's 3 x's, so we got x to the third is my leading term. If I multiplied them all, that'd be a 1 out there in front. So there we go. So once again, it's odd. Odd means they go in different directions. And it's positive, so it means it ends up positive, ends up going up, which means it starts going down because it's odd. It's got to be different 2 turns. Okay, and then this little hump is going to be greater than this one because look at the units in between. So you can draw it really, really accurately. All right, but these are just really sketches of graphs. So as long as you have something like that, you are monies. All right, let's keep going. There's a lot of pages here in this unit. Should we do one more? I think you guys kind of get it, all right? And there's like no tricky ones there, so I think everybody would be okay. All right, let's go ahead. Next level. Okay, this says writing a polynomial function from its zeros. So now what we are going to do is we are going to backtrack it, and we're going to go backwards, okay? I'm wondering if I want to go backwards yet. Do I? Okay, multiplicities is right there. All right, we'll go in the order of these pages. Let's go backwards. Okay, so now how would it go backwards? Well, this is like the ending. So let's think of how we went last time. So if you notice my last step in the previous couple problems, that was it. Okay, now let's think about this. Everything in math, you want to go forward, you want to go backwards, because then it means you just have it down pat money and you've got it mastered. All right, so let's think about this. How did I get there? Well, we would add 2 to both sides here. So that would be called a 0, right, class? Do you remember that? Now, what would we do here? We would subtract that 2 over. So there's that 0, right? And then what do we have here? We have x minus 3 equals 0. Okay. Now, what did we do after that? Well, okay, we kind of wrote this, and I think I gave myself a little bit too much room here. And then we wrote this as like a polynomial function in what we called factored form. Remember, we wrote y equals, and then that would be x plus 2, x minus 2, and then x minus 3. But guess what we have to do here? We have to write these in standard form, which means, sweet, we get to do some multiplication. All right, so let's go ahead and do this multiplication. I find out that these problems, when you have 3 of them, it's always most intelligent to do the back 2 first. All right, so what do I mean by that? Well, I'm just going to rewrite this guy, and I'm going to multiply these 2 guys. I'm going to take that x, spling, share it with both of them. Gives me x squared minus 3x. And then that guy's done, so spling, and then I get negative 2x plus 6, and then we get y equals. I'm going to simplify a little bit so it's not causing me more work. I can combine the x terms. Okay, and then, oh, sweet, I'm not even done yet. Awesome. So that means I have to distribute again. I'm going to share this x to all 3 of those guys. So then we get x to the third minus 5x squared plus 6x gone. And then I'm going to share that 2 with everything, which gives me a plus, 2x squared. Almost lost my handwriting there. Pays to write nicely. Boom, and then let's collect like terms, and we're done. So x to the third, that guy goes with that guy. That'd be a negative 3x squared. That guy goes with that guy, negative 4x, and then plus 12. That is in standard form. Done! I don't know about you, but that was kind of fun. It does take some work, but the good thing about problems that take a lot of work, that means I can give you a lot of points, right? All right, let's just do one more. All right, let's see which one here looks a little crazy. You know which one does is this one has a 0 and a fraction in it. So we're going to do this one as our last one, okay? So we have x equals 0. Okay, that was an answer. X equals 4. Boom, that was an answer. X equals negative 1/2. Okay, and I know I gave myself a little bit too much room there. Okay, and then remember, if this was 0, then that just means x equals 0. This one would be x minus 4 equals 0, right? And then this one here is a little bit tricky. Okay, what I want to do first is the way we would solve this is we divide it by 2 at the end. So let's multiply by 2, okay? And we get that. Okay, if we multiply by 2, that's what would happen, right? Multiply 2 on both sides. And then we're going to add that 1 over. So I get x equals 0, x minus 4 equals 0, and 2x plus 1 equals 0. Okay, okay? And then we're going to bring it all together, right? We got y equals x. Remember, usually if it's just x, we just keep it there. You could put it in parentheses if you wanted to. Okay, class? And then we get that. And then what did I tell you to do? It's usually most helpful if you take those two guys first. So this is awesome because I love multiplying. Spling, spling. 2x squared. Share that with that guy. Plus a 1x. Gonzo. Share that guy. Negative 8x. Share that guy. Negative 4. Okay, so then we get y equals x on the outside, and it's 2x squared because I got to collect like terms. Negative 7x minus 4. Am I done? No. We have to have it in standard form, which means we cannot have any parentheses. So it's y equals. I'm just going to share that x 1, 2, 3 times. And I get 2x cubed minus 7x squared minus 4x. Problem is donezo. That's it. And if you have 4, it's just going to take you that much longer, but it's that much more fun. All right, that's it. If you're struggling with your distributive property and your multiplication, I will see you in the morning. All right, let's keep rolling. Problem 4, finding the multiplicity of a 0. Okay, what the heck does that mean? What are their multiplicities? How does the graph behave at their zeros? Okay, so we have something here in function notation. Function notation just means they use this very fancy f of x, which is really the same thing as if it was y. Okay, so that's first and foremost. How do we find multiplicities? How do we find the zeros? How do we find out what behaves at those zeros? Well, you put it in factored form. How do we put a trinomial in factored form? Well, first I take out a GCF, right? GCF, right? What's the GCF? Well, they all have x squareds in it. All right, they all have x squareds in it. So let's take an x squared out of everything. And that would give me x squared minus 2x minus 8. Okay, because division, that's what we do when we factor, and that's what happened if we divided an x squared out of all those guys. Now, oh, sweet, that's a super duper fast way. Okay, let's do that super duper fast. 1 times negative 8 is negative 8. That's a negative 2. That'd be a negative 4 and a 2. Spling, spling. And I can do that super duper fast. So we got x squared. Let's do that super duper fast, which would be x minus 4, x plus 2, right? Okay. Now it says, okay, we want to find zeros. We want to find multiplicities and all that. And we're going to talk about that right now. Okay, so here we go. This here is that's x squared equals 0. That's important. That means that we all know that this guy's 0 would be x equals 0, and we say that it has a multiplicity of 2. Niban. Now, this is so cool, because whenever you have a multiplicity that's even, that means it bounces. What the heck are you talking about, Mr. T? I'm going to show you in a moment, okay? Now, this one would be x minus 4 equals 0. Now, that's x minus 4 to the first. So that means this is x equals 4, and we say that this has a multiplicity of ichiban. Now, if it has a multiplicity that's odd, that means it goes through it. It goes right through it, okay? Like the ones we've been doing. That's a multiplicity of 1 also. So then that means this guy, when I should write 4 comma 0, right? That's negative 2 comma 0. We'll put an A there, we'll put a B there, and this would be 0 comma 0. We'll put a C there. Now, what the heck would this look like graphically? Let's go ahead and take a look. Okay, I've got to erase for us to be able to do that. Come on, get rid of this stuff. All right, so if it has a even multiplicity, it bounces. If it's got an odd multiplicity, it goes through it. Look, what the heck would this look like? Let's check it out. All right, so we have 0, 0. Okay, what did I call that? I called that C. We have 1, 2, 3, 4, 0. We called that B. We have -2, 0, and we called that A. All right, now what the heck happens? Well, I need to know the leading term. Oh, sweet. I don't even have to think about it. The leading term is right there. The leading term is what the heck just happened? The leading term is 1x to the fourth. Now, oh my gosh, that's even. So they both go up or they both go down, and there they both go up because Ichiban is positive. All right, so they both have to go up. So I like to cheat. So it's got to start up. It's got to end up. That's the first thing I like to do. And then I have to remember at multiplicity, at 0, 0, it bounces. What the heck does that mean? At A, it goes through because it was a multiplicity of 1. And at B, it goes through because it was a multiplicity of 1. Okay, so it's got to bounce at C, go through at A, and go through at B. Okay, so let's go through at A. Through. Okay. Now, what the heck? It's got to get to C, 0, 0, but it's got to bounce. So what the heck would that look? Bounce. And then it goes through. I don't know about you guys, but that was pretty cool. And just make sure these guys are always polynomials, so they're nicely curved. Okay, they should all be like U's or N's, be nicely turned and curved. Okay, but that is how we deal with multiplicity. Some of us, we're going to have to really practice this stuff in class, and don't worry because we will. Okay, let's go ahead and look at another one of these guys. Well, these are all, this one here, I'm just going to talk about it really quickly. We won't graph it, and it doesn't. Okay, it just asks how they behave. But if this is my function right here, right, we can factor. All of those have something in common. What do they all have? They all have an x, right, which would be x squared minus 4x plus 4. Oh, sweetie sweets. That means, ooh, and actually this is a good one. We won't go all the way through this guy. I like it. All right, that means I can factor that bad boy, and I can do it the super duper fast way. 1 times 4 is 4, and that's a -4. So it's a 2 and a 2, but they both have to be negative. Okay, so they're the same. Well, that's interesting. So then we get y equals x. And then I can do it the super duper fast way, which would be an x minus 2 and an x minus 2. Okay. Oh my gosh, these guys are the same thing. So you know what? I could get fancy here, and I could write it as x minus 2 squared, and I'd want to. Why? Because what is that? That's even. All right, let's find our zeros. X equals 0. Okay, that means we have a point at 0, 0. And what does that mean? That means it has a multiplicity of Ichiban. What happens if it has a multiplicity that's odd? It goes through it. Okay, all right, now let's go ahead and do this one. This is x minus 2 equals 0. X equals 2. That means you get 2, 0. Ooh, that was a multiplicity of an even number. Multiplicity of 2. And what does it mean if it has a multiplicity of 2? It bounces, right? It bounces, right? What the heck would this graph look like? Oh, no, please tell me I didn't erase all of it. I may have erased all of it. Gosh darn it. All right, I think I can remember it though. Okay, I think it was 0, 0 with a multiplicity of 1. We'll call that A. And it goes through it, right? Multiplicity of 1. Sorry, you guys. I've got to write this down so I have my good notes. And then it was 2, 0 when we solved it. I remember that, and that we will call that guy B. And that was a multiplicity of 2, and it's going to bounce. Okay, it's going to bounce. So let's see what this would look like. So we have 0, 0, and we have 2, 0. Okay, and we'll call that A, and we'll call that B because that's what we define those guys as. Oh, there's my leading term, x to the third. It's a 1. X to the third means they go different. It's positive, so that means we're going to cheat it. It ends up, and it starts down, right? And then what happens here? It goes through A, and it bounces at B. Let's see if that works. Goes through A, bounce. Sweet. It worked out beautifully. My M behaviors worked out beautifully. That's how we deal with multiplicities, okay? Do you got it? I hope so. Bunch of problems here. We'll practice them in class. I'm going to get this video done. It's taken some time, all right? But we are almost done, okay? And believe it or not, this last little stretch right here, we do by our calculators, all right? Because they're asking us what mins and maxes are, all right? So what I need all you guys to do is get out your calculator. get out those calculators, and we're going to go boom, and I'm going to get my problem here. Okay, there's my calculatora. We're going to move that guy a little bit, and then what we're all going to do is we're going to go to y equals, and we're going to plug that function in. So the rest of today is using our calculators, okay? X to the third. X to the third. What do we got here? Plus 3x squared plus 3x squared. So type it in with me, you guys. Practice makes perfect with these guys, okay? Minus 24x minus 24x. Okay, and what do they ask us to do? What are the maxes and mins? Okay, so now we're going to go zoom. Remember, it's always best to graph our functions as zoom 6 in that standard viewing window. All right, let's see what we look like here. Okay, there's my polynomial. Okay, I can't see the max and I can't see the min, so I'm going to go back to window, and I definitely need to go higher and I need to go lower. Okay, but if you look in terms of the width, the x's, it was good to go. So I'm not going to change any of that. What I am going to change is my scales. Remember, it's always, I think, helpful to have scales of 0 so you don't have all those tick marks. I'm going to go down to -50 because I do not want to be searching all day. I'm going to go as high as 50, and then hopefully that will be in my picture. All right, let's see if it is scale of 0. Hit graph. Remember to hit pause and go back. Oh my gosh, this dude is way up there. If you look on low enough, right, it's got the minimum in there, but it doesn't have the max in there. So I'm going to go back to window, and I've got to change how high, which would be the y max. And I'm going to go to hundo because I don't want to be doing this forever, right? It's already taken me more than enough time. I want to be done. Sweet. That's a max. That's a min. So how do we find maxes and min? It is that second calc button. Okay, and guess what? Let's find the max first. So we'll do number 4. Okay, you go up to where you think the max is. So you're going to tick, 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 and you go all the way up to it. Okay, now remember, this is a max. It says left bound. That means you go to the left 2 times. Just make sure you're definitely to the left. Okay, and hit enter. And then you go to the right at least 2 times, but make sure you're definitely to the right, and then you hit enter. Okay, there it is. Now, whenever it says like -4.001, it really just means -4. So it's -4, 80. So on a test, dang, I get free points if I just say, hey, the relative max at negative, oh snap, what was it, class? What was it? -4, 80. -4, 80. So what we would like to say is it has a relative max value of 80. And where does it happen? It happens at -4. Okay? All right, let's go ahead and go to the next one. Okay, let's go ahead and find the minimum. And we'll only have to do one of these. You guys make sure you're practicing them at home. Second calc. All right, this time we're going to pick a minimum, which is 3. And then I gotta take this guy, right? Ooh, did I get it? Something didn't happen right on mine. Uh-oh. Am I frozen? Hopefully not. Let's go second. My calculator is not working, you guys. All right, we'll go back here. Let's see. I think you guys kind of got the gist. Yes, no, maybe so. I hope so. I can't click anything here, you guys, and I'm not going to waste any more of your time on this videos. All right, class, I don't know what to do. I've been trying to fast through it, but this min and max thing isn't working out for me. So we did this right here, okay? And then what I'll do is we'll either practice this in class or there will be a part 2 to this video because we have a very important word problem we need to get to. Okay, but for now, I'm going to have to give you the little alohas. Make sure you guys come in for help if you need it, okay? Aloha.